first of all, let's think about what this does. We are in 3 dimensions, but you see that z is missing, right? That means no matter what z is, you get just this shape. Now, this is some kind of circle, you know that, right? We will have to complete the square in order to find out exactly what the center and the radius is. But this is some kind of a circle. So what that means is that at every level z, you have a circle, the same exact shape. Okay, so what kind of geometric 3D object would you get? You're going to get a cylinder, or tube or pipe that's like in the z direction. So that's what this is going to do. This one we've done several times. This one is the double cone. We just call it a cone. But there's the x and y. There's a cone that's going up and then down. 2 cones right there. All right, so let's try to figure out what this one is. X squared plus y squared, subtract 2y both sides. And to complete the square, you have to take half of -2, which is -1. You square -1, you get +1. That's the number that you have to add both sides. So you add 1 both sides. So that this now becomes y minus 1 squared equals to 1. And since 1 is same as 1 squared, we know that the radius is 1, and the center of the circle is 0, comma, +1. So the picture is you have 0, comma 1, which is this point, and from this you have a radius 1 circle. That's what you're getting. Okay. So imagine the following. It's like this is the origin, and you have let's say this direction is the y direction. Okay, then you have a cylinder. Let me use a different color because it's confusing. You have a cylinder like that. Right here. You have a pipe that's going like that, right? And it's saying the solid is captured inside this cylinder, but outside this this cone. Okay, so it's as if you took this cylinder and you cut it using you hold out a cone-like thing, so that you end up with something like this. It's hard to draw, but that's basically the idea. That's a shape. And then you can see that the density is constant along the z-axis. And because of that, if you cut this object exactly in half, you would see that this is going to be, these two will have the same amount of mass, okay? Like, as before, the way we are going to calculate mass is sum of small bits of masses, and that's rho dV, right? That's the way we are going to calculate this, because definition of rho is you take a very small portion, measure its mass, divided by its volume. That's the definition of density, right? So just solving this for dm, it gives you that dm is rho dv, so that's how you get that. Okay? And that means we just have to do a three-dimensional, a triple integral with this going in, replacing the rho. Right off the bat, you should recognize that this is a bit tough if you try to do it using rectangular coordinates, because you have to describe this curve, which is, if you solve for x or y, if you try to solve this for x or y, it's not so pleasant doing this, right? So the way to do this is, first we'll just take only this portion. So half of mass, the half of mass is going to be equal to, and our strategy would be to use polar coordinate system, and we will we'll try to figure out what to do here. Okay, so first of all, oh sorry, I said polar coordinate, but I really meant cylindrical coordinate system. So we still have the z. So dz goes inside, and z starts from 0 right here and ends at the top surface, which is given by this one. Okay? So what do you get if you solve this for z? You get z equals to plus or minus square root of x squared plus y squared. But it's a top cone, so we would need x squared plus y squared, square root, and 0. And you're integrating rho. And then we will have the r dr d theta somewhere here, and we're trying to describe this region. Okay. All right. So going back to this region, how are we going to describe this? Well, unfortunately, this circle is not centered at the origin. So when you try to describe it, you have to say where it begins, where it ends. It does start at 0. That's not hard to see. But what is this curve if you changed it into polar coordinate system? That's a critical question that you have to answer in order to put the correct bounds for the r and d theta. Okay? And you do it like this too. So to convert x squared plus y squared equals to 2y, we use r squared equal to x squared plus y squared, and also that y is equal to r, which one? Sine or cosine? R sine theta. Right? Yeah. So we use that, and let's see what we get. That therefore this side is going to give you r squared. On the right side we get 2 times y, but y is replaced by r sine theta. Okay. See what I did? I just replaced x squared plus y squared by r squared because they're the same, and y by r sine theta. Now, r does become 0 right here, but other than that, except for the origin, r is never 0, right? So just be aware of that. We're just going to divide r both sides. If I divide r both sides, divide by r, so you get r equals to 2 sine theta. And one thing that you have to check is whether this still passes through r equal to 0, and the answer is yes, because if you put theta equal to 0, it does give you r equal to 0. So it's not like we're losing anything by dividing the r out. Okay, so the graph that you get by doing this one, or whether you do this one, you get the same exact graph. Okay. Another way to think about it is like if you move this to the other side and factor by r, it's like r times r minus 2 sine theta. And if you solve for it, you get r equal to 0, and you get r minus 2 sine theta equal to 0. Oh, don't write this part. I'm just trying to add more context here. What is r equal to 0? That's just the single point at the origin, right? What is this one? That gives you the full circle. Right? I explained last time that one petal rose is going to give you just this full circle, right? Yeah. It'll be a circle that's connected, that touches the origin. That's what that's going to give you. So it turns out that you don't really need this because this already contains this point. So that's not necessary. So that's what's really going on. I was just trying to explain in case you get worried about whether you're allowed to divide both sides by r or not. Okay, so that's what we have. So this curve, so what we just showed is that this curve right here is 2 sine theta. That's what it is. And therefore, how do you paint this region radially? You start from 0 and you end at 2 sine theta, right? So that should give you that r goes from 0 to 2 sine theta. And rho is square, oh. Okay, so here's another problem. We need to convert this to r and theta. What does this one become if you write in terms of r and theta? Well, the thing inside is r squared, right? So if you take the square root, you get r. So rho is going to be same as r. This one also will be r. Okay, and then you get dz. And then r dr d theta. Okay, so we're almost there. We just need to figure out what the angle theta should be. What should be the beginning and end of the angle? Right? 0 to pi, right? 0 to pi. So we need to put 0 to pi. Okay, so we just have to compute this, and that should be the answer. One thing that many people will make mistake in is, remember, this is half the mass. So at the end of the day, you have to double this answer to get the full thing. And another thing is, oh, maybe that's not, okay. Oh, we might need it. Okay, so this probably requires the formulas that I talked about last time, which is cosine squared of A is 1 plus cosine 2A over 2, and sine squared of A is 1 minus cosine 2A over 2. Yeah, during the exam, this should be given to you, so you don't have to worry about using this formula. But unfortunately, you have to use this twice, so it's not an easy interval. It requires some calculation. So because of that, I still want to show you how you do the remaining calculation. First of all, when you're integrating by z, r is considered as a constant, so this will integrate as r times z. Okay, and then you're plugging in r and 0. You still have to integrate by r and then also by theta. Okay, so this here is a result after integrating by z. You have to plug in r in there, so you get r times r times r. So you have 3 r's, right? So that means you have to integrate 0 to pi, 0 to 2 sine theta, r cubed dr d theta, whose integral is going to be 1/4 of r to the 4th, and then you have 2 sine theta, 0, and you still have to integrate from 0 to pi. D theta. Then you plug in 2 sine theta into r, 2 to the 4th power, what's that? 16. So you get 1/4 times 16, and then you get sine to the 4th power theta, d theta from 0 to pi. And then 16 divided by 4 is 4. Let's bring out the 4 outside. And you rewrite sine to the 4th as sine squared times sine squared. And we are going to apply for each one of them this formula. Okay, 2 times 2 is 4. Yes. Oh, okay. I thought you had a question. 2 times 2 is 4. And then, because these two are being multiplied, you have to FOIL this out. So 1 times 1 is 1. 1 times negative cosine 2 theta. 1 times negative cosine 2 theta. So you have 2 of these. And then finally, when these two are multiplied, negative negative is positive. So you get cosine squared 2 theta. And see, there's no challenge in integrating 1 nor 2 cosine 2 theta. That's not hard to integrate. But again, if you have cosine squared, anytime you have even powers of trigs, you have to use this formula because it gets tricky, okay? So you need to rewrite this again using the top formula, which is plus 1 plus cosine 4 theta over 2 d theta. And now we can do the integral for everything. Okay, so what's the integral? Integral is 1 integrates to theta. Cosine 2 theta integrates to what? Sine 2 theta, negative, no. Yeah, cosine 2 theta integrates to positive sine 2 theta, but there's a minus, so it's still minus. And because of this 2, it's going to create a 1/2, right? So it'll be 2 times 1/2 sine 2 theta plus, this 2 is just a constant multiple, so you don't have to do anything about this 2. We just have to integrate 1 and cosine 4 theta, right? So again, 1 integrates to theta, and cosine 4 theta integrates to 1/4 sine 4 theta, right? And to this, you have to plug in pi and 0. All right. What's sine 2 pi?
0.
0. This actually becomes used again and again for differential equations, the next class that you have to take. Sine is 0 at 0, and pi, and 2 pi, 3 pi, and every integer multiples of pi, sine is 0, okay? And that's a handy fact to know because that means when you plug in pi and you get sine 2 pi, oh, that's an integer multiple of pi, so this should be 0. What's sine 4 pi? For the same reason it's 0. So that's going to give you pi here. This will be 0. This will be pi plus 0 over 2, right? And then when you plug in 0, everything is 0. Sine 0 is 0, and everything is 0. So finally, this is going to give you, you can rewrite this as 2 pi over 2. So 2 pi over 2 plus pi over 2, that gives you 3 pi over 2. All right? So what's the answer?
3 pi.
3 pi, to double it, right? So the answer to this question is, I'll just write here, answer is 3 pi, because you have to double it.